Okay, this is 5.4b in college algebra, page 478, exercise set. This is number 27, and we're going to multiply those. So first step, we said we're going to write the name. They're both 3 by 3s, and because these two numbers are the same, it's possible to do. And this number and this number tell me what my answer is going to be. My answer is going to be a 3 by 3. So I'm going to make my blanks here so I know where I'm going to put numbers. I'm going to have 9 answers here. And we're going to do something a little bit different. We're not going to do necessarily this one first. Let's do this one first. Okay, so where this one is, this is in the second row in the third column. So all I'm interested in is the second row, third column. Okay? And that will give me my number right there. Okay, so I'm going to erase that red there, but remember, second row, third column. So I'm going to take, first of all, 0 times 0, 8 times 0, 0 times 1, and that will give me the number there, and I'm going to add them all together. Fortunately, all of these are zeros. 0 times 0, 8 times 0, and 0 times 1, so I know that this place right there is going to be a 0. Alright, so let's look at this one. Second row, so second row, second column. So I'm going to go 0 times 0, 8 times 4, 0 times 0. Okay, I add those together, and I get negative 32. Okay, let's do this one here. I've got row 1, column 2. Okay, so 1 times 0, negative 4 times negative 4, and 3 times 0. So that will give me, when I add all those up, 16. And let's look at this one. So we're talking first row, third column. 1 times 0, negative 4 times 0, 3 times 1. So that row will be, or that number there will be a 3. Let's see, how about this one here? So we're talking third row, first column. So 2 times negative 3 is 6, and then these are both going to give me zeros. So my answer is going to be a negative 6 here. And let's see, let's look at this one. So that's bottom row, middle column. Negative 2 times 0 is 0. Negative 1 times negative 4 is positive 4. 5 times 0 is 0. So I get for an answer a positive 4. Okay, and I just keep going through, and I end up getting a 3 there, a 0 there, and a 5 there, and I'm good and done. Alright, so let's look at a different one here. Let's look at number 28. We have 4 and negative 5, and we also have 2, 0, 6, negative 7, 0, negative 3. And they want us to multiply those. So we have a 2 by 1 and a 3 by 2. Okay, notice those numbers are different, which means I cannot do these. These are not defined. It's not possible to multiply these, so I'm done. Okay, if you look at number 25, same thing. It's a 3 by 1 and a 2 by 3. So not going to work. It's not defined. You can't do it. Okay. So let's look at example 7 on page 476. Dalton's Dairy produces non-fat ice cream and frozen yogurt. The following table shows the number of gallons of each product that are sold at the dairy's 3 retail outlets 1 week. So there's the picture. Let's make the matrix. Matrix is easy. We'll call it D for dairy. And we're going to put 100, 80, 120, 160, 120, and 100. Okay, that is a 2 by 3 matrix. So What do they want us to do? They haven't really told us yet. On each gallon of no-fat ice cream, the dairy's profit is $4, and on each gallon of frozen yogurt, the profit is $3. Use matrices to find the total profit on these items at each store. So what I have there is the number of gallons of no-fat ice cream and frozen yogurt. And what we're going to do then is we're going to make a matrix for the profit. So profit is on, what did we say? On the non-fat ice cream they make $4, and on their yogurt they make $3. So we've got a matrix there, and this is a 1 by 2. Okay, so this is important here. If I write this as 1 by 2 and as a 2 by 3, I can multiply them. But if I switched them around, I cannot multiply them. So multiplication with matrices is not what is called commutative. It's not like 3 times 2 equals 2 times 3 in regular math. These work, they're commutative. Matrices are not. So what we have to do is make sure that we write our matrices in such a way that they're going to work. So I'm going to write it as a 1 by 2 and as a 2 by 3. So I'm going to write it as a 1 by 2 times a 2 by 3. So that it works. So let's go ahead and do this one. So we've got a 1 by 2 and a 2 by 3, meaning that our answer is going to be in a 1 by 3. So I'm going to write that as a 1 by 3. 1 row, 3 columns. Alright, so let's do that. So first row, right there, first column is going to be first row, first column. 4 times 100 is 400, 3 times 160 is 480. So 400 plus 480 is going to be 880. Okay, next one is going to be first row, second column. First row, second column. 4 times 80 is 320. 3 times 120 is 360. So that's going to give me 680. Okay, first row, third column. So 4 times 120 is 480. 3 times 100 is 300. So we're going to get 780. Okay, so what that tells me is the total profit on non-fat ice cream and frozen yogurt for was $880 at store 1, $680 at store 2, and $780 at store 3, because this was my store 1, this was store 2, and this was store 3. Okay? So, if we have a matrix, new problem, if we have a matrix that has just columns, just one column, here, here, and here, 3 rows, 1 column, doesn't matter how many rows, but if we have 1 column, it's called a column matrix. If it has 1 row, but lots of columns, it's called a row matrix. Okay, not very difficult. Matrix equations, bottom of page 477. All right, this is pretty easy stuff. Let's say that I have 4x plus 2y equals, minus z equals 3. 9x plus z equals 5. 4x plus 5y minus 2z equals 1. And what I want to do is write a matrix equation equivalent. Okay, there's just one rule in doing this, so that's what we're going to do. We're going to write the matrix of this here. So 4, 2, negative 1, 9, 0, 1, 4, 5, negative 2. So we're going to write that matrix. Then we're going to write another matrix here, and we're going to put our variables in it. Okay? And then we're going to write our answer in another matrix, 3, 5, 1. Okay? We're going to call this first one here A. We're going to call this one, because it has variables, capital X, and we're going to call that one B. So what we're going to do then is we're going to say that AX equals B. Okay, that's all I'm worried about in this section. That's all you need to be able to do, is given a system of equations like we had up here, right here, be able to write it as a matrix equation. AX equals B. And just get what these, how to form this that we have here. Okay, and we will go into matrix equations in the next section on what to do with those. But at this point, I just want you to recognize what we did and be able to do that. Okay, so that is the end of 5.4.